Mm. Good evening, all. Can you hear me? Yes. So we have finished the synopsis for solution chapter. So today I'll be starting with MCQs. So we'll wait for another 1 minute for others to join and then we can start the class. Okay. So one by one, what you can do till we till we start the class, you all can just drop your name, okay, full name, in the chat box, so that it will be marked as a attendance. So you have to be present till the end of the class. Okay, I'll be checking it. So just write your name, complete name, in the chat box. Okay, so we'll start with the MCQs. Meanwhile, you can just drop your name in the chat box. So we have already completed the synopsis part. So last class I have briefed it in short. Okay, so today we are going to start with the MCQs. So this is the first MCQ. Okay, so the first question is, so if 2 grams of NaOH is present in 200 ml, okay, it is present in 200 ml of its solution, its molarity will be. Okay, so this is the question. Okay, so how you will calculate it? So what is molarity? Yes, what is molarity? Molarity is what? Number of moles of solute divided by volume of solution in 1 liter, right? So this is molarity. So we have to calculate if 2 grams of NaOH, okay, NaOH, sodium hydroxide, is present in 200 ml of its solution, what will be the molarity? Okay, so the way you have to solve this, first is what? Molarity is number of moles of solute divided by volume of solution in liter, right? So first step, molarity is given as number of moles of solute divided by volume of solution in liters. Okay, so this is the formula. Then, so you know what is given? What is given? So volume is how much? Volume is 200 ml, right? So 200 ml is your volume. Now we'll convert this ml into what we want in liters, right? So how do you calculate volume? That is ml into liters. Yes. How do you calculate ml into liters? So 200 ml is equals to, so you have to divide it by 1000, right? 1 liter is equals to 1000 ml. So 200 ml divided by 1000. So that gives you what? 1 by 5, right? So 2 ones are 2, 5s are 10. So it is 1 by 5 liters, right? So this is equals to 0.2. So this will come to 0.2. Then, so what is the this solute? It is 2 grams of NaOH. Now, so 2 grams of NaOH is given. So 2 grams of NaOH. Okay, it is given mass. So this is the what? This is your given mass. So what is given mass? Given mass is 200 2 grams. Okay. So then, so now we have to use the formula. So now we have to calculate the number of moles. Okay, how do you calculate the number of moles? So first we have converted your volume, okay, that is ml into liters. Now second step is what? We have to calculate this number of moles of solute. How do you calculate the number of moles of solute? So number of moles of solute, that is given as small n, is given as given mass. Okay, given mass divided by the molecular mass. Okay, divided by the molecular mass. So what is our given mass? Given mass is 2. What is given mass? Given mass is 2. What is the molecular weight of NaOH? What is the molecular weight of NaOH? Yes?
40.
It is 40.
40.
Yes, it is 40. Okay, so now what we'll do? Now we'll find the molarity. So now we know what is the number of moles, and we know what is the volume of the solution. We have converted the ml into liters. So now we'll substitute the formula. In the formula, we'll substitute this So molarity is equals to, okay. So what is the number of moles? Number of moles is what? Number of moles is 2 by 40 divided by 1 by 5. Okay. So 1 by 5 I have taken like this. Okay. In fractions I have taken. So that equals to 2 by 40 into 1 by 5. It will become ulta. Okay. It will become 5 into 5. So 5 ones are 5, 8s are, okay, 40. So 2 ones are 2, 4s are. So this is 1 by 4. So 1 by 4 is nothing but what? 1 by 4. So what is your answer? Just check. 1 by 4 means what? It is 0. What is the answer? 1 by 4. Yes, 0.25. So answer is A. So A is the correct answer. Okay. So did you understand this question? So what is how we, so it is a simplest problem. So I'm just starting with the simpler questions. Okay. I have taken some simpler questions this time. So after this, we'll go on increasing our what? We'll study some hard questions. So we'll go from a simpler question to advanced question. So this is the simplest question. So the given mass is 2 gram of NaOH. It is present in 200 ml of its solution. So you have to find the molarity. So molarity, how do you calculate? Molarity is nothing but number of moles of solute divided by volume of solution in liters. Okay. So here the volume is given, and what is given you have to see first. So what is given? Volume is given, that is 200 ml, and given mass is given. Okay. So this is given mass, and this is your volume, right? So this is given quantities. Now, what first you have to do? So you know molarity is what? Number of moles of solute divided by volume of solution in liters. So we want to convert this ml into liters. So how you have to convert 200? So 1 liter is 1000 ml. So 200 divided by 1000. Okay. So just do the this. Okay, just divide it. You get 1 by 5 liters. Okay. So this is the volume you get in liters. Next step is what? We have to find the number of moles of solute. So how do you calculate number of moles of solute? So it is by given mass divided by the molecular mass. So this is the formula here. So number of moles is calculated by the given mass divided by the molecular mass. So what is given mass? It is 2 grams. So what is the molecular mass? It is 40. So just substitute now in the formula, that is molarity is equal to number of moles of solute divided by the volume of solution in liters. Okay, so that is 2 by 40 divided by 1 by 5. Okay, so just cross multiply and you get 1 by 4, that is equals to 0.25. So this is the molarity. So our answer is A. Okay, so I'll go for the next question. I hope you have understood this question. Yes. So shall we move for the next question?
Yes, ma'am.
Okay, I hope you have understood. So we'll go for the next question. So the atmospheric pollution is generally measured in the units of, okay. So the options are A, mass percentage, B, volume percentage, C, volume fraction, D, ppm. What is ppm? ppm is parts per million. Okay. So the atmospheric pollution is generally, so how the atmospheric pollution, that is the pollution which is occurring in atmosphere. Okay. So how it is measured? So you know, since the amount of pollutants, okay, the amount of pollutants present in the atmosphere is very small. So you know the amount of pollutants which are present in the atmosphere, they are very small. Okay. So because of that, the atmospheric pollution, so it can be measured in terms of ppm. Okay, ppm, you know what is ppm? Parts per million is what? It is used to calculate the finest, okay, very small entity. So that is ppm. So it tells you about the you can calculate in a very small this. So the atmospheric pollution is generally, it is measured in the units of ppm. So the answer is D. Okay, the answer is D. Mass percentage, you know, mass percentage. Okay, so that is mass percentage is nothing but suppose 5 grams in 500 ml, right? 500 grams. So like that, mass percentage. So you're calculating the mass percentage here. Volume percentage, it tells you about the volume. Okay, 5 ml in 100 ml. Okay, dissolved in 100 ml, like that. So volume fraction. So ppm. So ppm is the it tells you about the smallest. Okay, so that is it. It is useful for what to detect the small entities. So your ppm, that is pollutants which are present in the atmosphere, can be measured in the ppm. Okay, so this is the second question. So the answer is ppm, parts per million. So next we'll go for the next question. A 5% solution of cane sugar, molecular weight is given as 342, is isotonic with 1% solution of substance A. The molecular weight of X is, okay, a 5% solution of cane sugar. So what do you mean by 5%? Yes, what do you mean by 5%? 5% means 5 grams of cane sugar. 5% means 5 grams of cane sugar, okay, in 100 ml of solution. Okay, in 100 ml of solution. Okay, so that is 5%. So this is 5% solution of cane sugar. So what do you mean by 5% solution of cane sugar? So it is 5 grams of cane sugar dissolved in 100 ml of solution. Okay, now is isotonic. Now what do you mean by isotonic? Yes, anyone? Can anyone tell me what do you mean by isotonic?
If two solutions have same osmotic pressure at given temperature.
Yes, when two solutions are having same osmotic pressure at given temperature, they are said to be isotonic. So, it is isotonic means they are having same osmotic pressure. Okay, same osmotic pressure. So both the solution with different concentration, they are having same osmotic pressure. Now, with 1% solution of substance A. So there are two solutions. One solution is of cane sugar, another solution is unknown. Okay, so that is A. So that is 1%. So what do you mean by 1%? So that is 1 gram, 1 gram of substance. Okay, in 100 ml of solution. So, so it is what 1 gram of substance in 100 ml of solution. Okay, so so this is a given quantity. Now what they have asked us the molecular weight of X. So we'll just write. So this is what it says. Okay, 1% and this 5%. Now what all are given? Okay, so W1. So what is W1? We'll consider. So there are two substances. Okay, there are two substances. I'll take with another color. Okay, so there are two substances. Substance 1, which is that cane sugar. Okay, it is cane sugar, and substance 2 is what? It is X. Substance 2 is A. Okay, now what is W1? W1 is 5 grams. Okay, that is 5 grams is the mass. Okay, then W1 is what? We are calculating the mass. That is this. Then the M1 is what? M1 is the molecular weight. So what is a molecular weight? So molecular weight of cane sugar is 342 gram per mole. Okay. Then what is the volume V1? So that is 5% means what? 5 grams dissolved in 100 ml. So the volume is 100 ml. Okay. So 100 ml. Now this is for, these are the given quantities for cane sugar. Now for substance 2. Okay, now for substance 2, that is A. Now what is W2? So we'll take it as W2. W2 is what? 1 gram. Okay, so we don't know the molecular weight. So M2 is, we don't know. And volume V2 is what? So V2 is what? It is 1 gram of substance is dissolved in 100 ml of solution. So it is 100 ml. So these are the given quantities. So you know it is isotonic. Okay, so it means now isotonic means what? R1 is equals to R2. Okay, so that is what? So how is isotonic osmotic pressure given as concentration into RT. So if you write it for solution 1, so it will be C1 RT is equals to C2 RT. So R and T, they are constant, so it get cancelled. Okay, R and R, T and T gets cancelled. So therefore, C1 is equals to C2. So the concentration of C1 is equals to concentration of C2. Now you know that what is that? Concentration. Okay, how is concentration given? So concentration is given as number of moles of solute divided by volume of solution. Okay, divided by the volume of solution. So number of moles of solute divided by the volume of solution is given as concentration. Okay. So so that we will express now. So this is the concentration. So now we'll write, so that is W1. So that is equals to W1 into M1 into 1000 divided by V1 equals to, that is C1 is equals to C2, right? So C1 is given as what? Number of moles of solute divided by volume of solution. So that is given as W1 divided by M1 into 1000 into V1 is equals to W2 divided by M2 into 1000 into V2. Now we'll what we'll do? We will okay, so now we will just substitute the given values. So what is W1? So W1 is 5. What is M1? M1 is 342. Okay, into 1000 into what is V1? 100 equals to what is W2? W2 is 1 divided by what is M2? We don't know, into 1000 into 100. Okay, so this is, so here 1000 and 1000 get cancels, 100 and 100 get cancels. So it will be what? So M2 is equals to 342 divided by 5. So just substitute. So after this, what you get, just see what you are getting answer. What will be the answer? Check. Yes, what will be the answer? What answer you are getting? I hope you are solving it. Yes. Yes.
68.4.
Yes, it is 68.4. Okay. So after solving this, you get it as 68.4. Okay. 68.4 gram per mole of substance X. So this is the molecular weight of X. I hope you have understood. Yes, you have understood. If no, if anybody has not understood, please say. I will explain it again. Yes. Understood? I hope you have understood. So what is given? A 5%. So there are two solutions, two substance. One is a cane solution and another is unknown solution. So a 5% solution of cane sugar, molecular weight is given. Okay, 5% means 5 grams of cane sugar in 100 ml of solution. Okay, so another substance X, it is 1%. Okay, 1% solution. So it is 1 gram of substance in 100 ml of solution. So these both solutions are what? They are isotonic with each other. Isotonic meaning what? They are having same osmotic pressure. So we write the given things, that is substance 1 and substance 2. So that is for cane sugar. So what is W1, what is M1, what is V1, W2, M2 and V2. Then from this we come to know that these are isotonic, means pi 1 is equals to pi 2. Okay, that is C1 RT is equals to C2 RT. So that is the osmotic pressure is given as this. So osmotic pressure of pi 1 is equals to pi 2. Okay, so because both the solutions are having same concentration, so that is C1 is equals to C2. So what is concentration? Concentration is nothing but number of moles of solute divided by volume of solution. So this is the formula. So formula is W1 divided by M1 into 1000 divided by V1 is equals to W2 divided by M2 into 1000 by V2. So after solving, so you substitute this, okay, and you get M2. So this is the way you are going to solve it. So I hope you are writing down the things. Yes, understood?
Yes, ma'am.
Okay, so we'll go for the next question. So 234.2 grams of sugar syrup contains 34.2 grams of sugar. Okay, so what is the molar concentration of the solution? So it is 234.2 grams of sugar syrup. Okay, so there is 234.2 grams of sugar syrup. It contains 34.2 grams of sugar. Okay, so that means what? So the weight of water. Okay, so we can calculate the weight of water here. So weight of water in sugar syrup. Okay, in sugar syrup is what? So 234.2 minus, so out of this much 234.2 grams, there it contains how many? 34.2 grams of sugar. So if you subtract from the total quantity, you get the weight of the water. Okay, that is 200 grams. Okay, now next is what? Next is molecular weight of sugar. So what is the molecular weight of sugar? Molecular weight of sugar is 342. Okay, so molecular weight of sugar is nothing but it is 342. So 342 is the molecular weight of the sugar. So molar concentration. So we have to calculate the molar concentration. So molar concentration is given as what? W1 divided by M1 in 2000 divided by V1. So what is W1? W1 is 34.2. That is the mass of the sugar. Okay, then what is its weight? It is 342. Okay, molecular weight in 2000, and we don't know the volume, that is V1. We don't know V1. So after okay, so just divide, first divide 34.2 divided by 342. First do this and then multiply it by 1000. So what is the answer you're getting? Yes. What is the answer you're getting? Which is the correct option?
0.5.
Yes. So the answer is 0.5. So you get,
Yes, ma'am.
so it is 0.5. Okay, so this is the correct answer. So the option, which is the option
B.
B. Okay, so option B is the correct answer. Okay, so so what is the question? So 234.2 grams of sugar syrup, it contains 34.2 grams of sugar. Okay, so what is the molar concentration of the solution? So what we have to do? So we have to subtract the water concentration. So what is the water concentration? So that is 234.2 minus 34.2 gives you the weight of water. So 34.2 grams of it is sugar. So then what is the molecular weight of sugar? Molecular weight is 342 grams, okay, per mole. Then molar concentration can be calculated as W1 by M1 into 1000 divided by V1. So that is 34.2 divided by 342 into 1000 divided by V1. So after solving this, you get to 0.5. So this is the molar concentration of the solution. Okay. So next question. So H2S is a toxic gas which is used in qualitative analysis. So if solubility of H2S in water at HTP is 0.195 molal, M small l n is M is molal, okay, molality. So what is, so always small m, it represents what? Molality, and capital M means molarity. So here it is molal, okay, molar. So that is, so here H2S is a toxic gas used in qualitative analysis. If solubility of H2S in water at STP is 0.195 m, what is the value of KH? Okay, KH is what? KH is Henry's constant. So we have to calculate the what? We have to calculate here the Henry's constant. So first, to calculate Henry's constant, so to calculate Henry's constant, so pressure is equals to KH into mole fraction. Okay, so this is the Henry's constant. So we can calculate Henry's constant by partial pressure is equals to KH, that is Henry's constant, into mole fraction. Okay, so so mole fraction, you know how to calculate mole fraction? Number of moles divided by the total number of moles. Okay, so that is number of moles divided by total number of moles. So this is mole fraction, how to calculate the mole fraction. Now they have given what? H2S in water. Okay, H2S in water. So what is molality given as? Molality, so we have to calculate the mole fraction for H2S as well as water. Okay, we have to calculate the mole fraction for H2S and we have to calculate the mole fraction for water. So there are two entities. Component A is H2S, component B is water. So molality is what? Molality is given as of H2S is given as 0.195 m, that is molality. So molality is given as what? Number of moles of solute divided by mass of solvent in kg. Okay, you know molarity is what? Molarity is volume of solution in 1 liters. Okay, and molality is number of moles of solute divided by mass of the solvent in 1 kg. So now let us consider, okay, let us consider mass of water. So what is mass of water? Mass of water is 1 kg because the solvent is taken is water. So let the mass of the water be 1 kg because it is in terms of molality. So we know the mass of what mass of solvent we know, and we know the molality. So we'll calculate the number of moles of solute. So number of moles is equals to molality into mass of solvent. Mass of solvent. So molality is what? Molality is 0.195 into mass of solvent is 1 kg. So it becomes 0.195 moles. Okay. So this is the what? This is for H2S. Okay. So this is the number of moles of H2S. That is 0.195 moles. Because it is given in solvent, so we have to convert the because it is given in terms of solvent, okay, that is kg. So we have to write, we have to convert it into kg. Okay, so that is number of moles is equals to molarity into mass of solvent, that is 0.195 into 1. So everything is given here. So we have to just, so it is number of moles of H2S is what? 0.195 moles. Okay, now we'll calculate the for water. So what is the molar mass of water? So molar mass of water, you know, molar mass of water is what? H is 1. So there are 2 hydrogen atoms. So 2 and oxygen is 16. So it is 18. Okay. So how to calculate the number of moles of water? So number of moles of water. Okay. So water, number of moles. So it is how much? 1 kg. 1 kg means 1000 grams. 1000 grams divided by 18 molecular weight. So it comes to 55.5 moles. So it comes to 55.5 moles. So we have calculated what? We have calculated both. So number of moles of H2S. Okay, so we have calculated both number of moles of H2S and we have calculated for water. Okay, so moles. So both the moles are known. So now we'll find out the mole fraction. So mole fraction. So mole fraction is equals to number of moles of H2S divided by the total number of moles of H2S plus water. Okay, so H2S is what? 0.195 divided by 0.195 plus 55.5. Okay, this comes to what? This comes to 0.0035. So to calculate the partial pressure, okay, so so here that is a pressure. So you know pressure at STP. Okay, pressure at STP is given at 0.987 Hg. Okay, it is 0.987 mm Hg. So this is the pressure standard. It is standard temperature pressure. This is the, so this is at standard temperature pressure. So this is the pressure, that is 0.987. So we know the partial pressure now. We know the what? So we have to, we know the mole fraction. So we got the mole fraction also. Now we can calculate the value of KH. So, so just resubstitute this, that is P is equals to KH into mole fraction. So KH is equals to P divided by mole fraction. So what is pressure? Pressure, standard pressure is given as 0.987 divided by what is the mole fraction? 0.0035. Okay, substitute and see. Substitute and see what you're getting.
282 bar. Option D.
Yes. Okay, so the answer comes to D. Okay, so the answer comes to 282 bar, that is D. So to calculate the Henry's constant, so what is the formula? Pressure is equals to KH into mole fraction. So standard pressure is given. So that is at STP, the pressure is 0.987 mm Hg. Okay, and what is this Henry's constant? We have to calculate. So mole fraction. So there are two components. So H2S and water. Okay. So it is given in molality. So we have used the molality. That is number of moles of solute divided by the mass of solvent. So as mass is taken in kg. So okay. So we have considered the mass of water as 1 kg. Then we have taken the number of moles. We have substituted what is the molality, what is mass of solvent, and we got the number of moles of H2S as 0.195 moles. Then we got the number of moles of water. So you know what is the molar mass of water. Then as water mass of the water is given in kg, so it is 1000 divided by 18. Molecular mass is given as 18. So we get what? 55.5 moles. So how do you calculate mole fraction? Number of moles of component A divided by component that is total number of components A and B. So that is 0.195 divided by 0.195 plus 55.5. It gives you the mole fraction, that is 0.0035. Then again substituting in the above formula, that is P is equals to KH into mole fraction. So we have to calculate the, which is our unknown quantity. Unknown quantity is what is that? Henry's constant KH. So KH is equals to pressure, partial pressure divided by the mole fraction. So after substituting this, we get the answer as 282 bar. So this is the way we are going to solve the question. Did you understand this particular question? Yes.
Ma'am,
Yes.
is that 0.987 is applicable for everything?
Yes, yes. So it is standard this pressure. Okay, 0.987 SGMM. So it is a standard pressure which is given. So it is applicable. So it is at standard temperature pressure. So this is the pressure for Hg. Okay. In terms of
Ma'am, whenever the STP comes, we can
yes,
mark
yes,
it as this thing, right?
yes, yes, yes.
Okay,
So
ma'am,
whenever STP conditions are given, you can use this. Okay. So this is the way you're going to solve this. Okay. Any more doubts before going for the next question?
No, ma'am.
Okay. So we'll go for the next question. So atomic mass is equal to, okay. So A, number of electrons of an atom. B, sum of the numbers of electrons and protons of an atom. C, sum of the numbers of neutrons and protons of an atom. And D, none of this. So atomic mass, how do you calculate atomic mass? A simpler question, okay. Not related to solutions.
Sum of number of electrons and protons in the atom.
Yes. So it is number of neutrons and protons, okay. So it is, the answer is C. The answer is C. So sum of the number of neutrons and protons. So neutrons and protons together are called as what?
Atomic mass.
Yes, they are called as atomic mass. No, you are calculating for atomic mass. But sum of the number of neutrons and protons, they are called as what? Protons and neutrons together are called as nucleons, right? They are called as nucleons. Remember this. So they are called as nucleons. You are calculating. So the sum of this, it accounts for atomic mass, but they neutrons and protons together are called as nucleons. So we'll go for the next one. So Henry's law constant for molality of methane is benzene. In benzene at 293 Kelvin is 4.27 into 10 raised to 5 mmHg. The mole fraction of methane in benzene at, it is benzene. Okay. At 293 Kelvin under 760 mmHg is, okay, in benzene at 298 Kelvin is 4.27. So this is the next question. So here what is given? So Henry's constant or molality of methane in benzene at 293 Kelvin is given. So 298 is a standard temperature. So KH, so that is what? Henry's constant is given as 4.27 into 10 raised to 5 mm Sg. Okay, then pressure, partial pressure is given. So pressure is given as 760 mm Hg. Okay, so here what we have to do, we have to calculate. So X is what? X is the mole fraction. So you know mole fraction. So according to Henry's law, so P is equals to KH into X, that is mole fraction. Now P is given as what? P is 760. Okay, P is 760 mm. Okay, Hg is equals to what is KH? KH is 4.27 into 10 raised to 5 into X is what? X is your mole fraction. So we have to calculate what? We have to calculate the mole fraction of methane. Okay, so mole fraction. So what we can do? We can keep mole fraction at one side and take this 760 divided by 4.27 into 10 raised to 5. Yes, see what the answer you are getting. 760 divided by 4.27. Just do that. Yes.
177.98 into 10 to the power of 5.
Yes. So it comes to 177 into 10 raised to minus 5. Okay. Now see the options. In options we don't have that into 10 raised to 5. So what we can do? We can just shift the decimal to 2 digits, this side, left side. So it becomes what? 1.78 into 10 raised to minus 3. Okay. So this is the answer. So our answer is what? Our answer is A. Yes, Jyoti, your answer is correct. So the answer is A. Okay, so Henry's law constant is given. So what are the given entities? So what is your job? So first you have to write down what is given. So your Henry's law constant is given. Then what is given? Your this pressure is given. So that is 760. So you have to calculate your the mole fraction X. So so you know the formula. So according to Henry's law, it is P is equals to KH into X. So the unknown entity, keep it at one side and substitute the other. So you get the answer. So this is the way you're going to solve this particular question. I hope you have understood. Shall we move for the next one? So I hope there are no doubts. So we'll go for the next one. So how much oxygen is dissolved in 100 ml? It is ml. Okay, 100 ml of water. 100 ml water at 298 Kelvin if partial pressure of oxygen is 0.5 atm and K is equals to 1.4 into 10 raised to minus 3. This is KH. Okay, KH is equals to 1.4 into 10 raised to minus 3 mole per liter per atm. So how much oxygen is dissolved in 100 ml of water at 298 Kelvin if partial pressure of oxygen is 0.5 atm and KH is equals to 1.4 into 10 raised to minus 3 mole per liter per atm. Okay. So Henry's constant is given. Henry's constant is given as
1.4 into 10 to the power of minus 3.
Yes, so KH is equals to 1.4 into 10 raised to minus 3 mole per liter per ATM. Okay. Now pressure, that is the partial pressure of oxygen, okay, is given as what? It is 0.5 ATM. So I'm just writing what all are given. Okay. Now, so what we have to calculate? We have to calculate how much oxygen is dissolved, okay, in 100 ml of water. So dissolved oxygen is nothing but we are calculating the solubility. Okay, we are calculating the solubility of oxygen in water. So we are calculating the solubility of oxygen in water. So it is given as what? KH into partial pressure of O2. So that is solubility of oxygen in water is calculated as KH, that is Henry's constant, into partial pressure of O2. Now what is Henry's constant? Henry's constant is 1.4 into 10 raised to minus 3 mole. Okay, per liter means it will come at bottom. So it will be liter and ATM. Per ATM means it will come at the bottom into what is the partial pressure? Just a second, I'll write it. Okay, so it is what? KH into partial pressure of oxygen. So KH is 1.4 into 10 raised to minus 3, okay, mole divided by, so per liter, right? So liter will come at the bottom into ATM. So ATM is also per, so it will come at the bottom into partial pressure of oxygen is what? It is 0.5 ATM. So this ATM get cancelled. Okay. So what you will get? 1.4 into 0.5. Yes, see. 1.4 into 0.5.
0.7.
Yes, it comes to 0.7 into 10 raised to minus 3, okay, mole and per liter, because ATM get cancelled. So, okay, so this is the this is the solubility of oxygen in water. It comes to 0.7 into 10 raised to minus 3 mole per liter. Now this is for, so 1 liter. So this is for 1 liter of, okay, so 1 liter of solution. So 1 liter of solution contains 0.7 into 10 raised to minus 3 mole per liter. Right, this is for mole per liter. This is for per mole. They have asked for how much? They have asked for 100 ml. So now we have calculated for 100 ml. So 100 ml means what? It will be 0.1 liter. Okay, 0.1 liter means it is 100 ml. So understood? So we have calculated the solubility of oxygen in water for per liter. Per liter means for 1000 ml. They have asked for how much? They have asked for 100 ml. So for 1 liter of solution, it contains 0.7 into 10 raised to minus 3 mole per liter. So 0.1 liter means 100 ml contains how much? It contains 0.7 into 10 raised to minus 3 into 0.1 moles of oxygen. So you have to multiply it by 0.1. Understood? So see, I'll write it again in the clear way. So for 1 liter of solution, it contains 0.7 into 10 raised to minus 3 mole per liter. So for 0.1 liter, that is 100 ml, it contains how much? So just cross multiply. So after cross multiplying, what you will get? Just see. So it will be 0.7 into 10 raised to minus 3 into 0.1 moles, right, of oxygen. So it comes to what? So this is the, don't substitute. So this is what you are getting for 100 ml. Okay. Now further, so mass dissolved. Okay. So now we have to calculate further. So it will be mass dissolved. So how much mass is dissolved? So mass dissolved is equals to number of moles into molecular mass. Okay, so how much oxygen is dissolved in 100 ml? So it is mass dissolved is equals to moles into molecular mass, number of moles. So number of moles is how much? It is 0.7 into 10 raised to minus 3 into 0.1. Okay, into what is the molecular mass of O2? O2. Each oxygen is 16. So there are 2 oxygens. So it will be 32. So it will be what? It will be 32. So it will be 32 gram per mole. So 0.1, right? 0.7 into 10 raised to 3 into 0.1 into 32 grams per mole. So after solving this, what you are getting? Just see. What is the answer you are getting?
2.24.
So it comes to 2.24. Okay, it comes to 2.24 into 10 raised to
Milligram.
minus 3. Okay, this is for grams. 2.24 into 10 raised to minus 3 grams. Okay, gram per mole it is. Now 10 raised to minus 3 means what? It is liters. Okay, that is L. So it is for 10 raised to 3 means 1000. So we have to multiply it by 1000. So you can so you have to convert it into milligram. So it will be 2.24. So when you multiply it by 1000, it comes to 2.24 milligram. Okay, so it is D. The answer is D. So 2.24 milligram. So this is the answer. Okay, so understood. So first substitute whatever you have got. So first you have got it for 1 liter. Then you have to calculate it for what? You have to calculate it for 100 ml. Okay, 100 ml. So after that you have to substitute and you get the answer. So it is 2.24 milligrams. So the answer is D. Okay, the answer is D. So I hope you have understood the questions. Okay, so one more question and we'll stop. The law which indicates the relationship between solubility of a gas in liquid and pressure is. So which is the law which tells you the relationship between a solubility of a gas in a liquid and partial pressure? Yes. Which is the law which tells you about the solubility of a gas in a liquid and partial pressure?
Rolls law.
No, not Rolle's law. Solubility of a gas in a liquid and partial pressure. KH.
Henry's law.
Yes, it tells you about Henry's law. So there are also Rolle's law. So it tells you about volatile liquids. Okay, it tells you about the volatile liquids. So that is a partial pressure of the volatile liquid is directly proportional to the mole fraction present in the solution. Then lowering of vapor pressure is not a law. Okay, it is a colligative property. So it is a colligative property. So it is not a law. So this is also wrong. So this is also strike out. This is also strike out. And Van 't Hoff's law is also wrong. So if any reaction is there, okay. So if any reaction is going on, so there will be increase in the temperature. So if it is there is increase in the temperature means there the endothermic reaction also. Okay, so it will result if there is increase in the temperature means it results into endothermic reaction. Okay, it results into endothermic reaction, and thus what happens, the rate also increases. Okay, so it is not concerned with the solubility. So this lowering of vapor pressure is also not concerned with solubility. So Henry's law, KH. Okay, so partial pressure is that is KH into mole fraction. So that is partial pressure, solubility of a gas in a liquid is it indicates the relationship between the solubility of a gas in a liquid and partial pressure. I hope you have understood the questions we have solved today. Yes. I'll just take a string. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Okay. So I hope you have understood the questions. Okay, what I have taught today. So if there are any doubts, you can ask, or we will end the session here and we'll meet in the next class. Any doubts? No doubts? Okay then. So we can, we'll meet in the next class. Okay. Thank you.